Today we are trying to solve the total coordinates table, or how to plot the latitude departure table. So this is how the question comes. You have your stations, your bearings with the distance. So this is the question that can be asked. A. Plot the survey by total coordinates. B. Calculate the closing error and the disclosure, taking the MV as 7 degrees west. So let's go straight to the solution. Okay, so to the solution. So this is how your table should be like. See, we have the station, the whole circle bearing, the quadrilateral bearing, this stands for x, sine x, the latitude, the north side and the south side. Then you also come to the departure. We have the east side and the west side, and also the total coordinates, that is the TC. We have the latitude and departure side, and we have the DMD. Then you come to the DA, which is what the double area. We have the positive side and also the negative side. So from the question, A, we were given a bearing of 112 degrees. So what will be the whole circle bearing of 112 degrees? And from the question, we were given magnetic variation or MV as 7 degrees west. And we all know that west, from the cardinal point, you all know that west is at the negative side. So always west is negative. So we subtract it from what? The whole circle bearing. But if it was the east, we add it. So if it's west, it's minus. If east, we add. So the bearing is 112. So 112 minus 7, the magnetic variation that was given in the question. That is 105 degrees. Then the second one, BC, we were given 97. So 97 minus 7, that is 90 degrees. And also CD, we were given 42. 42 minus 7, that is 35 degrees. And also DE, we were given 187. 187 minus 7, that is 180. Then EF, we were given 272 minus 7, that is 265 degrees. FA, we were given 347, that is 340 degrees. So we are done with the whole circle bearing. So this is how to find the whole circle bearing. If the magnetic variation is at the west, we subtract it from the main bearing. But if it's from the east, we add it to the main bearing. Simple. So we are at the quadrilateral bearing. So to find the quadrilateral bearing, first of all, let's draw our cardinal points. So it's drawn, it's this: the north, the east, the south, and the west. And I've already told you the formulas. If the number is, if the bearing is less than 90, it's in the first quadrant, and if it's 90, it's still at the first quadrant, that is due east. Then what to have, the bearing is what? Greater than 90 but less than 180, it's included in the second quadrant. But if it's equal to what? 180, that means it's what? Due south. And if it's greater than 180 but less than 270, it's included in the third quadrant. And if it's equal to 270, that means it's what? Due west. You see? So it applies to the same thing as the fourth quadrant. If the number is greater than 270, or the bearing is greater than 270 but less than 360, it's in the fourth quadrant. But if it's equal to what? 360, that means it's what? Due north. So this is how we are going to use to solve the quadrilateral bearing. So the first was 105. The whole circle bearing was 105. So where is 105 included? It's where? At the second quadrant. That means it's more than 180 but less than. It's more than 90 but less than 180. So the formula is 180 minus theta, or any variable you want to represent it. So 180 minus 105, that will give us 75. So where was 75? 75 was at the second, or the whole circle bearing. The bearing that we took 105 was at the second what? Quadrant. And the second quadrant is what? Southeast. That is the position, southeast. So you show the direction, or the position is what? Is south. 75 degrees what? East. So that's how you're going to do with the others. The same thing. So this is 90. So where is 90 from the cardinal point? 90 is where at the first quadrant. You see, that means 90 is equal to 90. So if theta is, I already said that if theta is equal to 90, that means it's what? Due what? East. Or you can write 90 east, but it's proper if you write what? Due what? East. Due east. So this one, the whole circle bearing is what? 35. So where is 35? 35 is less than 90. So that means it's at the first quadrant, and the position of 35 is what? Northeast. North, 35 degrees east. Then 180. 180 is aware, it's greater than 90, but what? Equal to 180. So that means it's where? At the second what? Quadrant. And the second quadrant also totals up to 180. So that means it's what? Due south. Theta is what? Due south. And the 365. 365 is greater than 90, greater than 180, but less than what? 270. And the formula for the third quadrant was x minus what? 180. And x is also the EF direction. So we have the whole circle bearing to be 265. And 265 is greater than what? 90, that's the first quadrant. Greater than 180, the second quadrant. But what? Less than 270 at where? The third quadrant. And from our previous video, we talked about 270, which are the third quadrant, and we talked about the formula for the third quadrant, which is what? Theta minus 180. So theta is 265, or any variable you want to represent it in. So 265 minus 180, which will give us what? 85. And where was the direction of what? The variable was what? At the southwest. So south, 85 degrees west. F it was given as what? 340. 340 is greater than 90, greater than 180, greater than what? 270, but less than 360. So that means it's where? It's at the fourth quadrant. And this is the formula for the fourth quadrant. 360 minus x or theta, as I said, any variable you want to represent it with. Okay. So 340. So 360 minus 340 will give us what? 20. So what was the position of the bearing? It was where? At the northwest. So north 20 west. So the distance was given in the question. So 3.05, 0.56, 2.50, 6.89, 2.75, 6.30. So these are the distance that was given in the question. Okay, so we are done with the sign X. Now we have the latitude section and that will be part of it. So from our cardinal point, the north, the east, the south, and the west. So we all know that at the north section here is positive. The east here is also positive. The south, which is what? Negative. And the west, which is what? Negative. And know that the latitude is what? The vertical section. So the vertical section, we have north and the south. Here are they. So the latitude is the vertical. We have the north to be positive and the south to be what? Negative. And also the departure, we have the east to be what? Positive and the west to be what? Negative. So how to find the section there, latitude section? You take the distance and the cos. The distance times the cos. That will be for what? The latitude section. And the distance times the sine will be for what? The departure section. So 3.05 times 0.2588 will give us what? 0.79. It gives us 0.79. But remember, we have the north section and the south section. So you come to your quadrilateral bearing. What was the position of your quadrilateral bearing? East, south, and east. So that means there is south here. So you position your 0.79 at your south section. But if it was to be northwest, that means our quadrilateral bearing is where? At the north. We put it what? At the north, but not the south. But here is where at the south. That's what it's placed in what the south section. So the second one, the distance is 0.56 times the cos, which is 0, which will give us 0. So you can either put the 0 at both places, or say the quadrilateral bearing, the direction was northeast, you can put it as only the north, only if you want it. But to make it very clear to you, you can put it at both sides. And also the third one, we have the distance to be 2.50 times 0.8192, which will give us 2.05. And where was the position of the quadrilateral bearing? It was where? At the northeast. So we have the north here. So 2.05 will come in 2.05. We place at the north section. Then we come to the fourth one. We have distance to be 6.89 times 1, which will give us what? 6.89. So what was the direction of the quadrilateral bearing? It was at where? The southwest. It was 180, so it was at the southeast. So south is here. We have the direction. It was at the south. So it's at the south, 6.8 what? 9. And also, with the fifth one, we have the distance to be 2.75 times the cos x, 0.0872, which gave us 0.24. 0.24. So what was the direction of the quadrilateral bearing? It was away, the south. So you place it under the south section. 0.24. And the last one, we have the direction to be 6.30 times 0.9397, which gave us what? 5.92. So what was the direction of the quadrilateral bearing? North and west. It was at the way, at the north. So you place your 5.92 at the north section. And remember, I believe you also that I've been placing it in 2 decimal places. That is the correct way to do. You put the cos should be 4 decimal places. But when you get to the north, the latitude and the departure section, place it under what? 2 decimal place. So that will be very easier for you to do. Even if you don't put it under 2 decimal places, if you can run it up after doing it, it's okay. But it will be very easier if you do it in this way, as I showed you with how to do it decimals with the calculator, the same way. Alright. So we are at the departure. The departure to the same way as we did the latitude. We have the east section, which is the positive, and the west section, which is what? Negative. So I told you here the distance times the sign will give us the departure. So 3.05 times 0.9659 will give us 2.95. 2.95. So what was the position of the quadrilateral bearing? Now we are done with north and south. We are dealing with what? East and where and west. So it was where? At the east position. So that means it will come to the east, which is positive. So here will be 2.95. Then the second one, we have the distance times the sign, which will give us what? 0.56. So what was the position of the quadrilateral bearing? It was at the east. So that means 0.59 will be placed at the east section. 0.56. So the third option. Okay. So we have the departure side. So the distance 0.56 times the sign, which will give us what? 0.56. So what was the position of the quadrilateral bearing? It was at the east. So you come to the east section, 0.56. So the third one, we have the distance times the sign, which will give us 1.43, which is 1.43. So the 1.43, where was the position of the quadrilateral bearing? It was at the east. So 1.43. Then the fourth one, distance times the sign here is 0. So the same way as we did with the latitude section, you either place your zeros here. So we come to the fifth one, distance times the sine. So 2.75 times 0.9962, which will give us 2.74, which will give us 2.74. So what's the position of the quadrilateral bearing at the west? So 2.74. Distance times the sine, which give us 2.15, which give us 2.15. So 2.15. What was the position of the quadrilateral bearing? It was at the west. So 2.15. So this is how we do the latitude side and the departure side. So right now we are going to the total coordinates. And before you can,
so I'll take you through the total coordinates. And under the total coordinates, we have the latitude section and what's the departure section. And under the total coordinates, the sign is taken into consideration. That the positive and negative sign is taken into consideration. So the latitude for station A and B is what? 0.79, but it's under what? South, which is what? Negative. So for the latitude under station A and B, I'll have negative 0.79. Negative 0.79. So I have to find what? The latitude for B and C. And to find the latitude of B and C, I'll add the value of this latitude towards the latitude under the total coordinates. But here is the case that under the station B and C, it's what? 0. So when I add 0 to negative 0.79, it will still be the same. So I'll have negative 0.79. So I have to find the next latitude under the total coordinates for station C and D. So what's the latitude? The value of the latitude for station CD is what? 2.04. It's a positive number since it's under the north section. So I have to add 2.04 to what? Negative 0.79, which will give me 1.25. Which will give me 1.25. You get it? So right now I'm coming to station DE. What's the latitude value for station DE? It's what? 6.91. Mind you, here we are using the corrected values, not the ones we didn't correct. So right now we are using these values, the corrected values. So the latitude is 6.91, and we have to add 6.91 to what? 1.25. So 6.91 plus 1.25 will give me 8.16. So I'll have my 8.16. Value for station D, the latitude is 6.91, and 6.91 is under what? The south section. So I have to subtract 6.91 from what? 1.25. So 1.25 minus 6.91, which will give me negative 5.66. So yeah, I'll have negative 5.66. With the next station, which is EF, the latitude is what? 0.24, and it's under what? The south section. So I have to subtract 0.24 from negative 5.66. So negative 5.66 minus 0.24, which will give me negative 5.990. Negative 9.90. So the latitude value for station F is what? 5.90. So I have to add 5.90 to negative 5.90, which is going to give me 0.00. So one thing that you have to notice under the total coordinates is that the last station, always the last station will give you 0.00. So let's get to the departure. So as we did for latitude, we do the same for the departure. And the departure for station A and B, we have 2.93, and it's under what? East, which is a positive value. So I have to write my 2.93. For station BC, the value is what? For the departure is 0.56, and it's what? Positive. So I have to add 0.56 to what? 2.93, which is going to give me 3.49. For station CD, the latitude is 1.42. So I have to add 1.42 to 3.49, which is going to give me 4.91. For station DE, the departure is what? 0. And I have to add or subtract from 4.91, but I'll still get the same value, 4.91. For station EF, the value for the departure is 2.75. So that means, and it's under the west section, so it's negative. So I have to subtract 2.75 from what? 4.91, which is going to give me 2.16. So for the last station, FE, the value for the departure is 2.16, and it's under what? The west section. So I have to subtract 2.16 from what? 2.16, which will give me 0.00. So this is how we go about the total coordinates under the latitude section and the departure section. So we are going to the DMD. You use the departure under the total coordinates for the DMD. So for station AB, the DMD is what? 2.93. But the DMD for station BC is adding this value, the first station value, to the second station value. So 2.93 plus 3.49, which should give you 6.42.
Which one plus the last coordinate plus
So
the first coordinate.
Yes, you have to add this value plus this value to get to it. This value. So 3.49 plus 4.91 will give you 8.40. So to find the DMD for station D, you have to add this plus this, which will give you 4.91 plus 4.91, which will give you 9.82. For station EF, 4.91 plus 2.16, 4.91 plus 2.16, which will give you 7.047. And for this value, this value plus this value, which will give you 2.16. Since 2.16 plus 0.00 will give you 2.16. So right now we come to the double area. The double area is what? Divided into two sections. That's the positive section and the negative section. But how we go about the double area is the latitude times what? The DMD. And mind you, the latitude is what? This section. You are going to use the latitude under this section to multiply the DMD to get what? The double area. You will not use the latitude under the total coordinates. You use this latitude to find the double area. So for station A, the latitude is what? Negative 0.79, and the DMD is what? 2.93. So 2.93 times negative 0.79, which should give you negative 2.01. So I'll place it here, 2.01, since it's what? Negative. For station BC, the latitude is what? 0. So 0 times what? The DMD, which is 6.42, is what? 0. So I'll write 0 here, 0 here. For station CD, the value, the latitude value is what? 42.04 times what? The DMD, the corresponding DMD, which is 8.40. So 8.40 times 2.04, which should give you 17.14, and what it's what a positive value, so 17.14. For station DE, the latitude value is what? 6.91, and it's what? Negative. So negative 6.91 times the corresponding DMD value, which is 9.82. 9.82 times negative 6.91, which will give you negative 67.86. So we have 67.86 in this section because it's what? Negative. For station EF, the latitude value is what? Negative 0.24 times the corresponding DMD value, which is 7.07. 7.07 times negative 0.24, which should give me 1.70. It's a negative value, so I'll place it here, 1.70. And the value for the last station, which is FA, is the latitude, which is 5.90, positive 5.90 times the corresponding DMD, which is 2.16. So 5.90 times 2.16, which will give you 12.74. So after you are done with this, you sum up the double area under the positive section and the double area under the negative section. So 17.14 plus what? Plus 12.74, which will give me 29.88. 29.80. Then I'll sum this one up to 2.31 plus 67.86 plus 1.7, which will give me 71.87. So this is the value for the double area. That's the, for the positive section is 29.88. For the negative section is 71.87. So right now I have to find the difference. I have to subtract the smaller value from the bigger value. So double area is equal to 71.87 minus 29.88 minus 29.88, which should give me 41.99. 41.99. But I have to leave my answer in what? A single area. This one is the answer for a double area, but I have to leave my answer in a single area. So I have to divide this double area into 2 to get my single area. So 41.99 divided by 2. 21. So right now I have my area to be 21 hectares. I have my single area to be 21.00 hectares. So So after this, you are done, but you are not done. You get it? You have to find the misclosure, and the misclosure is the formula for misclosure is closing error over what total perimeter. So this is how we find the misclosure. Closing error over what total perimeter. And the closing error is calculated by using the triangle to represent it. So the first error for the latitude was 0.05. So you have it here 0.05. And that of departure was 0.05. And I'm finding the hypotenuse, which is the what's closing error. So the closing error is calculated by root of this squared plus what this squared. So 0.05 squared plus 0.05 squared, which will give me 0.